All right. Okay. Guys, there are two triangles that automatically work for trig, and we like them. We like them because the numbers work prettily. And these are those two triangles. The 45, 45, 90 isosceles and the 30, 60, 90. Okay? Now, what do you know about isosceles triangles? You know that's 90. What do you know about these two? They're both 45. Now, what else do you know about an isosceles triangle? Kelvin? All the angles add up to 180. That is true of all triangles. Yes. What else do we know about them? We know nothing else about isosceles triangles?
A squared plus B squared equals C squared.
Yes, we know that because that is true of all right angle triangles as well, and this has a right angle in it. Lovely. That's two things down. We know something else about isosceles triangles.
It has a right angle.
Two sides are the same. Excellent. Which two sides? Not the hypotenuse. How do you find the hypotenuse? No. How do you physically find the hypotenuse? It's the longest side. You got your ruler out? It's the side opposite from the right angle. Thank you. That's the hypotenuse. So what do I know about these two sides? They're the same. In math class, what can I do for these two right now? I can give them a variable. What variable can I give them? Anything I want. If this is x, what's this? No. It's x. Because they're the exact same. Yes? Is everybody cool? And that makes the hypotenuse the square root of what? X squared plus x squared, which makes it 2x squared. Yes? Everybody's good? Now, as Bryce pointed out, at the very beginning of the parabola unit, every parabola is similar, yes? No matter what you do, you can always do something to that original parabola and get every other parabola in the world, right? Same thing here. This triangle, no matter the size of x, will follow a pattern, all right? And the pattern is this. What is the easiest number I can make x right now? 1. X is 1, x is 1. So what is the hypotenuse? Root 2. Is everybody cool with that? Which makes the following pattern available to us. The sine of 45 is what? All sines are what? Opposite over hypotenuse. So they are all 1 over root 2. Everybody cool? What is the cos of 45? Adjacent over hypotenuse, which is 1 over root 2. And what is the tan of 45? O over A, which is 1 over 1, which is 1. Now, you might be saying to yourself, what does this do for me? You're about to see. Okay? So everybody cool with this? So I got 45, 45, 90. I got a sine, I got a cos, I got a tan. And you know the first 6, don't you? These guys are all 1 over root 2, 1 over root 2, and 1. What happens in 90? Where is 90? It's right here, yes? So what would the sine of 90 be? Sine is opposite over hypotenuse, yeah? Everyone agrees? What is opposite of the 90-degree angle? The hypotenuse. So opposite is what? Root 2. What's the hypotenuse? Root 2. So therefore, what must the sine of 90 be? 1. Check on your calculator. What is it? The sine of 90. Wow, look at that. Myers. What is cos? Cos is adjacent over hypotenuse, yes? Okay, what's adjacent to the 9, to the 90? Which one? What's the cos of 90? Use your calculator. What is the cos of 90? Why? Why is the cos of 90 0? Because you can't do it. Why can't you do it? They're both adjacent. So the cos of 90 is 0. What's the tan of 90? Use your calculator. Can't do it. Why? Which is opposite? Which is adjacent? Everybody cool? Undefined. Now, come over to here. 30, 60, 90. Right? You guys are smart kids. Which of these angles has to be the 30? This one. Why? Because it's smaller and it's opposite the smallest side. So which has to be 60? Excellent. The top. Everyone cool with that? Okay. So in a 30, 60, 90 triangle, what is the simplest number we can use to mess around with it? 1. Where should I put the 1? Right here. Why? Because it's the shortest side, yes? Everyone agree? Everyone agrees, right? Yeah? Okay. So, if we have this number and one side, can I use trig to find the other two sides? If I have this number and this number, can I use trig to find the other two sides? I can, can't I? Right? So, if I put x here and I put h there, can I use trig to find this? What would I do to find x? What are my two options? Pardon me? I could do tan 30, couldn't I? So I could go tan 30 equals what, Nav? 1 opposite over adjacent, yes? Then I could use my calculator to find x. What is it? It should be a yucky number, isn't it? It's barfy, right? You guys don't recognize it. So that's not a great one, is it? But we could do it, right? What else could I do to find x? What else could I do to find x? Tan 60 equals what? X over 1. which means tan 60 equals x, yes? Okay, what's tan 60? 1.717, right? Sorry, not 717, that's 71, yeah. You don't recognize that, do you? Shh, I know that, Lucas. Some of you don't recognize what that is, do you? Because it gives you a decimal, yes? What was it again? 1.73. ... right? You still may not recognize that. Okay, so that didn't really help us. Can I find h? What would find me h? Sine 60 would equal x over h, yes? Can't do that. I don't know x. I do now, but I didn't know it before. Could I do cos 60? Cos 60 equals 1 over h, yes? Well, what's 1 divided by cos 60? 2. Oh, I recognize 2, don't I? So what does that make h? Now we've got h as 2. Now it's real easy to find x, isn't it? X equals the square root of 2 squared minus 1 squared, yes? What's 2 squared? 4 minus 1, what's that? Root 3. And oh my good gravy, 1.73 is the root of 3. Got it? So what does that tell us? That tells me that in every 30, 60, 90 triangle, if I have a 1, a 2, and a root 3, I know my sine, cos, and tan. What do we know about every other 30, 60, 90 triangle? That it's similar to that, yes? So if this side is 10, what's this side? 10 root 3. What's this side? 20. If this side is 5, what's this? 5 root 3. What's this? 10. Got it? So what is the sine of 30? Every 30 is 1 over 2. Right? Because it's always 1 over 2. And if you check with your calculator, sine 30, what do you get? 0.5. What's the cos of 30? Root 3 over 2. And what's the tan of 30? 1 over root 3. What about 60? Root 3 over 2. 1 over 2 and root 3 over 1, which is just root 3, yes? Right? And then do I need to do 90? I don't need to. Why? So I already did it over here, right? We know what 90s are. So how does this apply to the trig we are doing right now? Well, let's figure that out. Is everybody cool with how we got all these? Going once, going twice, going thrice. All right, so turn your page over. There's the steps. Okay? Some of you guys like to see that. Some of you guys like to figure that out on your own. But there they are. When you have the steps, it's real easy. Sine of 45, yeah? Okay, so no calculator. We already know it. That's 1 root 2. So the sine of 45 is 1 over root 2. We already know how to do it. Right? Cos of 60. Now here, the 45, 45, 90 isn't too difficult. The 61 is. Right? Because it can be drawn in two different ways, can't it? If it's 60, then is it the red one? Or is it the black one? There's theta. There's theta. Which one am I doing? And does it matter? And then let me ask you this. Isn't that theta that theta? And isn't that theta that theta? So all you got to do is remember what it looks like, right? Right? Where's the 1? Because you know it's 1, 2, and root 3. Where does the 1 go? The shortest side. 1, 1. Where does the 2 go? The longest side. And now we're good, yes? Because I only wanted cos. Are we good right now? I want cos. Are we good right now? Cos needs an adjacent, doesn't it? I need the root 3. Correct? Now, where's the 60? The red ones are the 30. The black ones are the 60. So what's the cos of 60? Good? Tan 330. So now the first two are easy because they're in the first quadrant, yes? Tan 330 is not in the first quadrant. So how do I do this? I have to draw it, don't I? Where does 330 live? Down here, right? I go all the way around to 330. That's the triangle I need. Which means how big is this? 30. Once I have that 30, I automatically know what triangle am I using. 30, 60, 90. Across from the 30 is what? What's always across from the 30? 1. What's the hypotenuse? Always. 2. What's this? Root 3. Now look closer. Is this drawing drawn correctly? And then let me ask this question. Once you've decided if it's drawn right, is it labeled right? Something there is wrong. What's wrong, Joel? It should be a -1, shouldn't it? So now, can I do tan of 330? What is it? -1 over root 3. Is everybody cool with the special triangles? So 225, you guys should be able to recognize that without drawing it. Is that a 30, 60, 90 or 45, 45, 90? It's 45, 45, 90, right? 225 lives in the third quadrant, yes? So cos is always x over h. H is always positive. It's 45, 45, 90. What's my h? Root 2. And what's my... Has to be -1 because I'm in the third quadrant. Does everybody understand how I got that freshly out of my head? I didn't even draw it. Does everybody get how we found that? If you don't, what do you need to do? Draw it. So let's draw it. Where is 225? We know it's right down there, yes? And we know that this has to be 45, yes? And we know in a 45 it's always 1, 1, root 2, correct? And since I'm over here, it must be -1 and -1, right? Adjacent, -1 over hypotenuse, root 2, because it always has to be positive. Can everybody do D one way or the other? Either pulling it out of your head or drawing it. Great. So let's look at E. 240. Soon as you see 240, what kind of triangle is it? Has to be 30, 60, 90, yes? Okay. The 240 is what? The 240 tells me what? What quadrant it's in. What quadrant is it in, Joel? Third quadrant. So, if you don't need to draw it, you don't need to draw it, but some of you do. There is where it lives, yes? Which means this is my reference angle, yes? Which means it's 180 to 240. How far is that? $60, which means this is my 30, which means this is how long? What kind of one? Why is it -1, Kelvin? Because I've gone left. How long is this one? √3. What kind of √3? Why? Because I went down into the y-axis. How long is this one? 2. Why? It's the hypotenuse, and the hypotenuse is always what? Why? Why is the hypotenuse always positive? You're on the right track, Kelvin. I find the hypotenuse by squaring the sides, yes?
Yeah.
What happens when you square a negative? What happens when you square a negative? What happens when you take a square root? Stays positive. So that's why that's always positive. So now, what's the sign of 240? What's sign always? Opposite over hypotenuse. So this is the angle I need. So what's the opposite? -√3 over what? 2. You guys should be able to do the rest. Go. You should be able to do FGH. Draw it if you need to. There's no shame in it. Never. Yes. So, where's 210 going, Joel? Right there, yes? So what is this angle right here? Because that's the angle I care about. 30. Once I have 30, 1. √3, 2. Negative, negative. Right? It'll catch up. So what's the answer? For cos? Oh, there we go.
Sorry, it's -1 over.
Is it back yet? No, still not. What is it, Joel? -√3 over 2. Okay, what's 150? It's out here this time, right? Here's the 30. There's the 1, it's positive. There's the -√3, there's the 2. So what is it? -1 over √3. And sine of 315, down here, 315 is a 315? 45, 45, 90. So that's 1, negative 1, root 2. What's sine of 315? Negative 1 over root 2. Can everybody do that? What's the only trick? Remembering which way the 30, 60, 90 is turned, yes? And the only thing you have to do to remember that is remember 30 is always across from 1. And 60 is always across from root 3. Possible values. When I put possible values, what does that mean? There might be more than one, yes? So, for my cos to be negative, where must it live? Over here somewhere, yes? Right? Okay.
Probably.
And since it's root 3 and 2, what do you know? Is it a 30, 60, 90 or a 45, 45, 90? 30, 60, 90, right? Which one of them has to be 2? The hypotenuse has to be 2, which has to be positive, which means the adjacent must be my negative root 3, correct? So what's the only thing left? 1. 1 has to be across from what angle? 1 is the smallest, so it has to be across from what? 30, 60, or 90? 30. So that makes that 30 and that 30, correct? Are those reference angles or thetas? Reference angles. Where does theta start counting from? From 0. So there's that one, which is what? Why is it 150? 180 minus 30 to equal 150 for the red theta. What's that one? Blue theta, which is 180 plus 30 to get to 10. Everybody good? Okay, look at sine. It's 1 in root 2. So which is that? 45, 45, 90 or 30, 60, 90? 45, 45, 90, right? And since it's positive, where must theta live? There or there for sine, yes? Where's my root 2? Right there. Where's my 1? Right there. So since it's 45, 45, 90, where are the two 45s? There and there. What is red theta? 45, because it's the same. What is blue theta? And what's blue theta? 135. It's 180 minus 45. Is everybody cool? All right. Tan is negative. Where must it live? Quadrant 4 and quadrant 2. Has to be here, yes? Okay. And if it's tan, it is opposite over adjacent, yes? So this is over 1, right? So where is the opposite? What's opposite to my two thetas? I lie. What's opposite to my two reference angles? There and there, yes? This is quite easy to see that this is negative root 3, right? But this is positive root 3. How do I get a negative root 3? This must be negative 1 and this must be positive 1, correct? Right? So, here's where it gets tricky. Did I draw this very well?
It's alright.
Not really. Why?
Picasso's really good at this.
What's weird about the way I drew this?
It's uneven.
It's totally uneven, isn't it? This side, I drew it obviously longer than this side, didn't I? Right? But you guys know that this is 1, so what's this? 30. Even though I drew it badly, yes? Because what is the drawing for? Is the drawing there to answer it, or is the drawing there to help focus my thinking? Focus my thinking. Because if the drawing was there to answer it, I'd have a protractor out, wouldn't I? Yeah. So since that's 1, this must be 30, yes? Which makes this what? 60. Which makes this what? 60. Which makes me have red theta of what? 180 minus 60. And blue theta of what? 360 minus 60 to get it. Is everybody Gouda? Okay? Please, please, please hear me when I say this. Your drawings are there to help you. You are just sketching it. This is what you need to know. 1's across from 30. Root 3 is across from 60. Okay? Everybody good? All right. It is 9:15. You have 15 minutes left. If you look on your next page of notes, 164 and 165. Please look at those pages now. I call your attention to this word because you don't need it. All right? Now, normally, I would say an assignment is worth marks, yes? But I am also not a mean person, and I never make you do anything for marks unless I give you independent practice first, yes? Did you get independent practice before this? No, we did the notes. So this is not an assignment for marks. But for those of you that have issues with not hearing me, it still needs to be done. Okay? Okay. Page 164 to 65. I'm still not done. Remember, redundancies. Who do I talk to?
Oh, God, that's about a...
Don't tell me how much. Just
You got to take it down to the office. It has to go in. I wouldn't plan on getting it back for a long time.
like ever.
Maybe never.
Okay.
Probably right up.
Do your math. Joel, what was your question?
Yeah, when you say without a calculator, does that mean just like you can't like
You shouldn't need one,
yeah.
right? You're subtracting from 180.